Picking up where we left off yesterday, Prince, Harnor, that discussion can wait till later. Alright, so remember you have your mean value theorem, your Rolle's theorem. Yesterday was all about Rolle's theorem once we got through the notes. Today what I want to go through is just kind of review what mean value theorem says, do a fairly basic example, do a word problem to kind of show, I think Ryan asked yesterday, like, okay, cool, what does this have to do with, like, reality? So if cops could do math, they would pull off a lot more people if they worked in pairs, and we can see that in example 4 there. Then we'll pick and choose some problems from among the homework set, so you can kind of see what you have to do for the homework if you haven't started yet. So, mean value theorem. Conditions are that the function's continuous and differentiable, and that's it. So if your function's continuous and differentiable on some interval, you can use your mean value theorem, and you'll be guaranteed that the average slope over the interval will be the same as the derivative right at some point, somewhere in the interval. You might not necessarily be able to find out where, like with the car example over there, but we'll be able to prove that somewhere in the interval, the derivative is the same as the average slope. And maybe you'll be able to find out exactly where and get like a particular c-value. And to kind of have a picture of what that looks like, here's your curve. The green line represents the slope. So the slope of that green line is the average slope of the curve. And then the derivative at some point is the same because these are parallel lines. So somewhere here, there's a c-value where the derivative matches the average slope. And that's where we can see the tangent line is parallel to the secant line. And guaranteed there's going to be some point in here where that happens. Questions with just kind of big picture what the mean value theorem is saying? All right, let's look at example 3. So example 3, they give us an actual function, they give us an interval, and they say, all right, cool, where is it where the derivative equals the average slope? So the first thing you should check and see is mean value theorem even going to apply? So is this function continuous and differentiable? Well, where is it not continuous? 0. Is that in the interval? No, so we don't care about it. So we say, hey, it's not continuous at 0, but 0 is not in the interval, so we're cool. It is continuous and differentiable everywhere else. So point out discontinuity at x equals 0 is not in interval. So the mean value theorem allows us to proceed. Next, we get our average slope. So we're saying, all right, we're going to do f of 4 minus f of 1 over 4 minus 1. Plug in 4. What's f of 4? 4, because 4 over 4 is 1, and 5 minus 1 is 4. You plug in 1. What's f of 1? 1, because 4 over 1 is 4, and 5 minus 4 is 1. And so it turns out our average slope is 1, right? It's 4 minus 1 over 4 minus 1. Over here, then, we get the derivative, and we set it equal to the average slope when we try to solve. So take this thing, get its derivative. So what might be helpful to rewrite this as before we differentiate? Yeah, so rewrite it. 5. Oh, that's just 5 minus 4x to the negative 1. All right, cool. Differentiate that, and what do you get? 4x to the negative 2, which might be easy to work with as 4 over x squared. So you put that here, 4 over x squared. So now you've got your derivative on the one side. You just took the function and differentiated. You got your average slope of the function on the other side, where you just did your slope formula over the interval. And now you have them set equal to each other. So now you have the derivative equals the slope, and now you solve. So how are we going to solve this equation? Yeah, bring the x over. So multiply x squared to the right side. Square root that, and what are your solutions for x? Plus or minus 2. Now you look back at the interval, and you say, okay, which of those solutions get to be called C? Positive 2. So C equals 2, because that's in the interval from 1 to 4. X equals negative 2 is not in the interval from 1 to 4, so he's not C. So just positive 2 gets to be called C. I don't remember if I've told you this. That symbol means contained in this interval. That's it. Questions? Yes.
So, wait, the F prime is C equal. Wait, what's that equation called? F prime C equals that whole chunk.
That's the mean value theorem formula,
Okay.
I guess.
So the mean value formula, like plugged up in, and then we got, what did we get?
So we got the derivative on the left side. This is the derivative of the function. You've got the slope of the curve over the interval. So this is just your average slope on the right side. So this is basically derivative. Oh my goodness, it's this thing again, derivative equals slope. Where it's the derivative at some particular point equals the average slope over the curve, over the interval. But it's just another derivative equals slope formula. Rasa? What? Yes. I think. Yeah. Anything else? All right. Now let's talk about sort of real life. So you decide, actually, I hate working with other people, so I'm going to become a truck driver. You're driving your truck down the highway. It's tempting. I know a guy who's really smart, and he decided, screw it. I hate other people. They're all stupid. I'm going to go be a truck driver. He's much happier being a truck driver. So you're driving your truck down the highway. As you go along, you run into a cop, so you slow down as you approach the cop. I don't want to get pulled over. And then once you pass the cop, you speed up again. Because, that's what you do. And then you see another cop further along, and you slow down again. So as you pass the first cop, you're going 55 miles an hour. And then 5 miles, wait, is it 5? This is 5 miles. 5 miles later, you see the second cop, you slow down again, you're going 50 miles an hour. And so they're not going to pull you over. But if they talk to each other, and they point out, hey, there's this guy coming down the highway, he's the only truck on the road, I don't know how, and they clock you, like that 4 minutes in between, they'd be able to know, actually, this guy was speeding, we just didn't see it happen. But we can prove it because we're mathematical cops. So we want to prove at some point in that time period between the first cop and the second cop, you were speeding, you jerk, and we're going to prove that with the mean value theorem. So basics, we're going 5 miles in 4 minutes. Speed limit's only 65 miles an hour. Prove that you got faster than that at some point. Any questions with the general scenario? All right, so I kind of laid out our process of attack here. So first, I would recommend we don't use the given speeds. So the fact that you're going 55 miles an hour at the beginning and 50 miles an hour at the end is completely irrelevant information, only there to confuse you. We're not going to use what your speed is at the beginning or the end at all. That's not important. What is important is your position and the distance traveled. So what's your position at the beginning when you pass the first cop? 0. And what's your time? 0. So we'll say your position, S, at time 0 is 0. So we're going to use function notation so that we can apply the mean value theorem a little more easily. So function notation, we'll call position S, and at time 0, our position is 0. So we'll say position at time t is S of t. What's your position at the end? So how far have you gone? 5 miles. So we're doing things in terms of miles. And what's our time at the end? 4. Now that's for what? Minutes. But we're measuring speed in miles per hour. So let's convert 4 minutes into hours. Remember unit for conversions from chemistry? Who's taking chem? You guys love unit conversions in chemistry, like moles to whatever, everything else? No, it was like the worst thing ever. Yeah, I agree. All right, so this will be less bad than that. So you have 4 minutes. We want to convert that into hours. So 4 minutes times, all right, we want to kill minutes. Where are we going to put minutes in this fraction? On the bottom. So what's going to go on top? Because that's what we want to end up with. How many minutes to an hour? 60. Since you have minutes on the bottom, 60 minutes to 1 hour. Da-da-da. And you got 4 times 1, 4 over 60, reduces to 1/15. If you want to make it a decimal, hell, why not? What's 1/15 as a decimal? How about 0 point? No, it's not 0.6. 6 repeating? Yes? Like that? All right, cool. I'll take your word for it. So instead of saying position at 4 minutes, we want to do things in hours because our time or our speed is being measured in miles per hour. Let's turn this 4 minutes into 0.06 repeating hours. So that's our just kind of getting information down about our beginning position and our ending position in function notation so that we can then go ahead and use mean value theorem. Next, we use this stuff to find the truck's average speed. So we have the speed at the beginning and the speed at the end, but we want the average speed in that time frame. So the average speed is just going to be your average change in position. So your change in position, that's just using your this stuff. So s of 0.06 repeating minus s of 0 over 0.06 repeating minus 0. So you're now doing the slope formula from the beginning of the interval to the end of the interval. And on top, you put the actual positions then. That's 5 minus 0 over 0.06 repeating. Let's get rid of this. And what does that end up being? What's 5 divided by 0.06 repeating? That's 75 miles per hour. How do we know it's miles per hour? Because we're measuring speed, and we converted things into miles and hours. So it's miles per hour. So there's your average speed. Now we can apply the mean value theorem to draw a conclusion. Is it reasonable to assume that your speed as you drive along the highway is continuous? Like, is there going to somehow be a break in your velocity function as you drive along? No. I don't think that's even possible. Not in real life, because if you hit the brakes hard, you still have to go through all the speeds to get to the bottom speed that you reach. So, like, your velocity speed, your equation has to be something that's continuous. So, mean value theorem for position is definitely continuous and differentiable, so that applies. So we can assume that your position equation is continuous and differentiable because you can't just like teleport, right? That's not a thing. So since teleportation is not a thing, position is continuous and differentiable. So there must be a time where f prime of, I guess, position is s. S prime equals s of 4 minus s of 0. I'm sorry, 0.06. So there has to be a time where this happens, because that's your mean value theorem formula. And we know this has to happen because your position is continuous and differentiable. And now we know that this thing over here on the right side of that formula is 75 miles per hour. And s prime is just velocity, because the derivative of position is velocity. So there's some time where the velocity is 75 miles per hour, which is more than the speed limit. So you've been caught, get pulled over, you get a ticket. Ryan.
But if you divided 5 by 4, like 5 miles by 4 minutes, multiplied by 6.
Yes. But this way we get to use like the function notation to make it fit into the mean value theorem.
But
But yes.
Wouldn't it have been easier?
Yes.
So
But this way you get to fit it into the mean value theorem formula so you can kind of see how that works.
so it's not practical. but
No, it's not.
applicable.
Not in this scenario, except to kind of see how all the puzzle pieces fit together. But if you want to take a step further back and look at a bigger picture and do that, so I can find average speed by doing the distance traveled divided by the time. Oh, my time is in minutes times by 60. Then yeah, that works. Risa? Yeah. So then you could say greater than the speed limit, basically. Yeah. Probably we don't have to explicitly say, and 75 is bigger than 65, but yeah, that's basically what you're saying. But yes, you could point out, and then that kind of clinches the proof. You did it. Any other questions with that? Prince?
So the position at the beginning as 0 equals 0.
Yep.
Okay, and then below that as 0.06 equals 5.
Mhm.
So and then below that we just found the average speed.
Yep.
And then what did you do for like part 3?
Part 3, we're now like looking at our mean value theorem and saying, if this function is differentiable and continuous, and it is because we don't know how to teleport, then there has to be a place where its derivative, and the derivative of position is velocity, equals that average speed, which is 75. So, bless you. Since the derivative is velocity, and it has to equal 75 at some point in this interval, guaranteed we were breaking the speed limit somewhere in that interval between the two cops. So they would be justified in pulling you over, even though you would feel like they cheated, because they didn't actually see you with their own eyes breaking the speed limit. Like, I would be furious, but they got me. Any other questions? All right, so then for the remainder of class, I want to go through a couple of problems like what you'll see on the homework, do a couple of Rolle's theorem problems, and then do a couple of mean value theorem problems, like what you'll see if we have time. All right, back to Rolle's theorem. Real quick, Rolle's theorem has what conditions? All right, so Rolle's theorem conditions has to be continuous and differentiable everywhere on the interval. And there's one other condition.
Like f of b equals f of a?
Yeah. So the beginning and the end are the same. So f of b equals f of a. So where you are at the beginning is where you are at the end in terms of the height of the function. So in part 1 over on the left there, we want to see just, can we apply Rolle's theorem or not? Yes or no? And if not, why not? So f of x equals the absolute value of x. So just go through the conditions. On that interval, is absolute value of x continuous? Maybe it's helpful to have a mental picture of this. What does this look like? A V shape. So basically looks like this over the interval. So is that continuous? Is it differentiable? Where is it not differentiable? At 0. Okay, that's in the interval, so we can say no! Not differentiable at x equals 0. So we cannot apply Rolle's theorem. We cannot guarantee that there's a place where the derivative is 0. So if all that happens, then we guarantee f prime of c equals 0 somewhere in the interval. And then that's it. We don't even need to check the third condition because the second condition wasn't met. All right, this thing, f of x equals 1 over x squared. Can we apply Rolle's theorem? Why not? It's not continuous at 0. What's going on at 0? It's undefined. So no, undefined at x equals 0. What's going on at x equals 0? What makes it be undefined? Vertical asymptote. So remember those things. Hey, it's a vertical asymptote at x equals 0. That's a discontinuity. So no, Rolle's theorem cannot apply. All right, this next one, f of x equals 3x plus 7. Ah, finally, just a simple line. Can we apply Rolle's theorem? So is it continuous? Yeah. Is it differentiable? All right, now we get to check the endpoints. What's f of negative 3? What's f of positive 3? What is it? 16? All right, so f of negative 3 does not equal f of positive 3, so no. So we have 3 different functions and 3 different ways in which we can fail to have Rolle's theorem apply. Comments, questions on numbers 1? Yeah, so if it were just f of x equals x squared, then that would be cool, because x squared is continuous, and it's differentiable everywhere, and for x squared, negative 3 gives us positive 9, and positive 3 gives us positive 9. So if I made this not a fraction, if I just made this f of x equals x squared, then we would be able to use Rolle's theorem. And all that does is say, all right, cool, guaranteed, somewhere in this interval, the derivative equals 0. It's just a really specific version of mean value theorem where the average slope of the interval is 0 because the beginning and the end are the same height. Any other follow-up comments on numbers 1? All right, number 2. Now we go ahead and kind of go through it all the way. So determine whether Rolle's theorem can be applied. So is our function continuous? What kind of function is this? Parabola. Are parabolas continuous? Yes. Are they smooth? Yes, they're smooth too. No pointy pointers. No pointy pointers on parabolas. They're nice, smooth, curvaceous curves. So they're differentiable also. Can we apply Rolle's theorem? Let's check the beginning and the end. So what's f of 1? What's f of 4? 0. So f of 1 equals f of 4. So that checks out. So the function continuous and it's differentiable, and the function at 1 and the function at 4 are the same. So Rolle's theorem can be applied. So that means we go ahead and try to find where does the derivative equal 0. In order to do that, what do we now have to do to our function? Differentiate it. So you get f prime of x. What is f prime of x here? 2x minus 5. And what do you do with that? Equal them to 0. And you solve for x, and what do you get? 5 over 2. Double check. Does that live in the interval between 1 and 4? Yes. That is in the interval from 1 to 4. So c equals 5 halves. Ta-da! So that's kind of the level of what we're doing for the homework with Rolle's theorem. You have a little bit like this, where you just tell me, hey, why doesn't Rolle's theorem work here? And then a little bit like this, where here's a function, apply Rolle's theorem. Check if it works, and if it does, find out C. You might have a little more complicated of a function, but you went through all of chapter 2 for the last month. You should be able to differentiate just about anything that doesn't involve a log. So I'll let it to you guys to differentiate harder stuff on the homework if necessary. Any further comments on Rolle's theorem? All right. Then, let's see, what else do we have? So that covers us 1 through 17, which we're not doing all of those, picking and choosing from among 1 through 17 from the homework. And then the mean value theorem stuff, let's look over here. I didn't mean to erase that. I wanted that up for block 3. Damn it. Oh well. So try to copy this into your notes. I'm just going to draw a graph here. So this is A, this is B, and So find points on curve where f prime of c equals f of b minus f of a over b minus a. So I could just give you a picture and say, here you go. What's mean value theorem then? And you know it's mean value theorem because you see the mean value theorem formula, which is derivative equals slope over some interval. So the way to do this is you're going to want a straight edge. You guys know what a straight edge is? Yeah, thanks. So it's things that have an edge that's straight. So find a straight edge, line it up here, draw the secant line connecting the beginning to the end, and then you move your straight edge so that it stays parallel to that line and move it up or down until it's tangent to the curve. So this thing's annoying to work with. I wish I had an actual ruler instead of a whole meter stick. I've got like 7 meter sticks in there, and none of them are just a ruler. Oh well. So you play connect the dots, beginning to end. So, and then you slide this, keeping it at the same kind of angle until it's tangent to the curve. So I'm going to move it up. Tell me when to stop. Stop. All right. So, and boom. I missed the curve a little bit, but you get the picture. So it messed up my drawing a little bit, but you can still see it, I think. So about right there, the tangent line is parallel to the secant line. So that's a C value. Is there another point, do you think, where we might have another tangent line that's parallel to this guy? Yeah? All right, so what if I take this and go which direction now? Down. So tell me when to stop. Stop, all right. And then you, that sucks. Let's try again. That's better. So that's about there. So there's another C value. So you have a couple of C values where the derivative, that's the slope of the tangent line, equals the average rate of change. That's the slope of the secant line. So that's, if you see this sort of picture and you're being asked to do this, that's what you just draw it. Draw it, line up your ruler, connect the dots, align the ruler so it's tangent to the curve, and try to keep them parallel. Yeah, Ryan. Okay. So that's one of the things I think I have you guys doing on the homework. And then let's talk about how mean value theorem fails. When are we out of here? Oh, we got loads of time. So why doesn't mean value theorem apply for f of x equals x over x minus 3 on the interval 0 to 6? So we look at that function and we say, why would we not be allowed to use the mean value theorem to find C values where the derivative equals the average slope on this interval? Because we have a discontinuity at 3. So what's going on at 3? The denominator is 0. Graphically, what's going on? Vertical asymptote. So we have vertical asymptote at x equals 3. That gives us a discontinuity. So mean value theorem cannot apply on that interval for this function. Similarly, how about if we had absolute value of x minus 2 on the same interval? What's going on there to prevent mean value theorem from being usable? Discontinuous at 2 or sharp turn? So the derivative is discontinuous at 2 because there's a sharp turn in the curve. So sharp turn at x equals 2. And so that means f prime of 2 does not exist. So it's not differentiable even though it is continuous. So you'll have a couple of questions just like that. Hey, here's this graph, here's this function. Explain why the mean value theorem doesn't work here. I could give you a graph itself. I won't even give you the equation, but here's a graph. Why not? There's a hole, right? There's a discontinuity, there's a hole. And then the other kind of question we'll have is like what we had for example 3, where we just give you a function and say, all right, cool, show me that mean value theorem is allowable, and then find out the c value where the slope equals the average speed, or the derivative equals the average slope. So here about, this is number 44. We got f of x equals x minus 1 over x. And we're, never mind, that doesn't work. Negative 7 to 2. All right, the first two I looked at, they don't work. That's not. Oh, wait, they don't have to be the same. Yeah. All right, f of x equals the square root of 2 minus x. We're looking at the interval from negative 7 to 2. So you guys go ahead and start finding the derivative. Before you do that, is this thing continuous and differentiable on that interval? Yeah. Now, once you go past 2, the curve is dead. There's nothing past x equals 2 with this thing to the right. But as long as you're to the left of 2, this is cool and it's differentiable everywhere that it exists. So go ahead, find f prime of x to have your derivative. Get the average slope by doing your slope formula at the beginning and the end, and then try to solve it. And while you guys do that, I'm going to log into my other Google Meets for the day, because when I did that earlier, that laptop decided to kick me out of all of them. All right, so for f prime of x, what's our d in? Or did you not bother with d ins and d outs, just went ahead and did it? So what's our derivative? So negative 1 over, all right, so negative 1 over 2 times root 2 minus x. Did anybody leave it with exponential, with the exponent 1/2 instead of square root? It doesn't matter. All right, so you have this. Does anybody need to see getting that derivative? Once you got that, also over here, f of b minus f of a over b minus a. So for negative 7 and 2, what do we end up with? Can everybody get that? All right, what's f of 2? 0. What's f of negative 7? 3. So 0 minus 3, so that's negative 1/3. So you get your derivative, boom. You come over here, you do your slope formula, boom. And then what do you do? Is equal. So you now take your derivative and your slope and you set them equal because derivatives are slopes. So you have negative 1 over 2 times the square root of 2 minus x equals negative 1/3. Solve that. What do we do? Yeah, cross multiply. So multiply 3 over, multiply the 2 root 2 minus x over. Negatives cancel. Then what? Divide over the 2 so you can isolate your square root. Then to kill the square root, you square both sides. And you get 9/4 equals 2 minus x. So x equals what? So negative 3 over 2 plus 2, or that's not, negative 9/4 plus 2. Yeah. So I'm going to add the x to the left and subtract the 9/4 to the right. What's 2 minus 9/4? Is that negative 1/4? So there you go. Is that in the interval? Yeah. All right, cool. Let's call them C. Done. So that's kind of the level of what we're looking for the homework. And word problem similar to our car problem. Yeah, you could do probably number 59 is not assigned, but number 59 is a good problem to kind of look at. I think that's it. I went through the final exam and